Hey y'all, today we will be learning about power law of logarithm and how to solve it and what it is about and how it is used in real life. So this is the formula for power law of logarithms. Log bx exponent equals n log bx and then this. What is it? The exponent n is a logarithm expression can be rewritten as a coefficient in front of the logarithm. So the n right here comes to this side. This property simplifies calculations and applies to any base. The steps to do this, first we will write in an exponential form, raise both sides to the exponent of n, apply power law of exponents, write as a logarithm expression, and then substitute w equals log bx. And then these are the three questions that will be solving for you guys and helping you guys understand on how to solve it. So let's get right to it. So our first question right here is log 3 and 4. So let's do that. Where's my marker? So it's like this, and then we put equal. This 4 right here becomes a leading coefficient. So you will rewrite it like this. Okay, now we have that done. Now we will break down the 9. So 3 squared equals what gives us 9? I meant to say 3 exponent what gives us 9, but I accidentally said 3 squared. That is my apologies. So now we have this. Now we have the same basis, so this would cancel out right here in the whole equation. So it would be like this, and that would be 8. So the answer to this question is 8. Our next question is log 2, 8, 5. So same rules apply for how we did on the first one. Exponent is right here, leading coefficient. After we do that, we need to know what exponent will give us 8. So that would be, because 2 times 2 equals 4, 4 times 2 equals 8. So 2 cubed gives us 8. Okay, now same thing as we did before. This cancels out. So now the whole equation just becomes, then that would be 5 times 2 equals 15. And our last question for the day is 3x equals 10. This is more complicated than these other questions, and I'll explain why. In this one, we're given less information to deal with, so it's more confusing. But at the same time, this question is pretty easy if you use these. If you use the method I'm about to teach you guys. Okay. So first, we will log both sides. Don't mind my handwriting. Okay. Now we log both sides. This x comes in front, so it will be like this: x log 3 equals log 10. So basically the same rule. This is still exponent, so this will still become the leading coefficient. And then you will bring this to the other side. So x equals log 3 minus log 10. Then uh, the way you're supposed to do is, since it becomes subtraction, you're supposed to divide. If it's addition, you're supposed to multiply. So this would be log 10 over log 3. Now let me put that in a calculator real quick, and I get equals 2.1. And these were the questions. I hope it made sense, because it made sense to me. Now let's go back. Now, how this is used in real-life applications. So it's used in engineering and science. Logarithm formulas are used in earthquake analysis to measure the energy released by earthquakes. The power law applies logarithms to compare large difference in power, such as measuring sound intensity or signal strength. Finance and economics, that's another way it's used. Logarithms are used to calculate compound interest, analyze exponential growth in investments. For example, they can determine how long it takes for investment to double. And this is the end of my video, and I hope it made sense. If it doesn't make sense, you guys need to rewatch the video. It's really simple to do it. You guys bring the exponent to the front, which becomes a leading coefficient, and then if the base is a 2 and the number is an 8 right beside it, so you would basically need to put something to exponent what to equal to that number. So since it's 8, you will put 2 cubed. That would equal 8. So you guys cancel out the same numbers. So which will be left with exponent. I hope this made sense. Thank y'all.